Okay, fine. In the last lecture, we discussed about how to prepare the fundamental cut sets. Then, how is the column-wise addition? It will do equations and row-wise addition. Then finally, we discussed about the equilibrium equations. And today, we will try to discuss about the procedure for finding the current and voltage using the cut set matrix. Is it right? Now here, to begin with, I will discuss the procedure first. Here, the procedure for finding current and voltage using cut set matrix. How is the procedure? What are the steps? Step number 1. Draw the oriented graph for the given network. First, we will prepare the oriented graph. Then, select the tree and prepare the fundamental cut set matrix, that is QF. Yes, we will prepare the fundamental cut set matrix using rules which we have discussed for the preparation of the fundamental cut set matrix. Then we will prepare the branch admittance matrix YB for the given network. And the order of this matrix is B into B, where B is the number of branches. And when we have this YB and QF, we can find out the QF transpose. And we will prepare cut set admittance matrix YC using the relation YC is equal to QF into YB into QF transpose. This matrix multiplication. This YC is equal to QF into YB into QF transpose, where this QF is the fundamental cut set matrix, YB is the branch admittance matrix, and this QF transpose is the transpose of the fundamental cut set matrix. After getting these equations, we will prepare the current source matrix as given below. Here IS1, IS2, IS3, ISB, these are the branch currents, because our assumption is that each branch is standardized to this level. Each branch is standardized to something like this, where this is the branch admittance, which is YB, and this is ISB. IS stands for current source and B stands for the branch number. If it is for the branch 1, it will become IS1 and so on, because our assumption is that the network consists of the standard branches. If not, we have to convert into the standard format. How are the entries? This may be the plus or minus entries we have to take for the current sources. I will discuss about the entries. The elements in the IS matrix are taken as the positive. This entry will be positive. When it will be positive? If the branch current and current source attached to that branch has the same direction. In that case, current in this branch, assume the current in this branch as well as the current source direction. If both this direction and this direction, if it is same, then it will be taken as a positive. If one is a forward and another is the backward, in that particular case, this current entry or current source entry will be taken as a negative, that is minus. That is the preparation of the current source matrix. Then after that, we will use the equilibrium equations which we have prepared for this cut set. And that equilibrium equation is YC into VC. This YC is nothing but cut set admittance matrix. This YC is nothing but cut set voltage matrix, which is equal to minus QF into IF. This minus is the sign which we have shifted on the right hand side of that equation. QF is the fundamental cut set matrix. IS is the current source matrix. We will prepare this equation. And from that, we are able to find out these values of the cut set voltages. Indirectly, it is nothing but the node voltages. And if we know these cut set voltages or node voltages in this case, then branch voltages are calculated by using this equation, that is VB is equal to QF transpose into VC. This equation we have got from the equation of the cut set, maybe column-wise addition or row-wise addition, we will get the two equations. This is one and this is the another. That is IB is equal to YB into VB plus it is IS, where IB is the branch current, YB is the branch admittance matrix, VB is the branch voltage matrix, and IS is the current source matrix. Means these are the ways of the calculation of the current. This method is almost very similar to the reduced incidence matrix. Only difference is that in the reduced incidence matrix, this is nothing but Vn, that is node voltages. This is the reduced incidence matrix. This Is is as it is, and these equations are also similar. In place of this QF transpose, it will be the A transpose. That is nothing but reduced incidence matrix transpose, and this equation is almost same in that particular case. Is it right?